Alright guys, this week we're going to talk about symmetry and transformations. Now, transformations is the majority of what we're going to cover this week, but we are going to spend about 1 day's worth of work here on symmetry, and this should be easy stuff, hopefully things that we kind of know from either real life or other math classes. So, you're probably familiar with the idea of symmetry. You see it in lots of different places. Most things that get built have some sort of symmetry to them. Or if you think about people's faces, if you kind of cut a person's face down the middle, like with a line, you take a look at it, usually the left side and the right side are fairly symmetrical. So that's actually only one of the two types of symmetry that we're going to talk about. There's two types we want to talk about. There's line symmetry and there's rotational symmetry. So here are the two types, and I've combined a couple of different shapes that have different types of symmetry to them. So let's take a look at this first shape. I've got kind of a half circle here. And with this half circle, this has line symmetry. And what we mean is we can draw a line roughly down the middle. Let's clean that up a little bit. That's kind of a rough line. Let's try that again. All right, here we go. All right, not much better. In fact, even worse. Last time, here we go. There we go. All right, so we got a line. It looks like it's cutting that half circle about in half, right? If we took that half circle, we could fold it up on top of itself, and it would have line symmetry. Now, there's a second type of symmetry, rotational symmetry. The idea of rotational symmetry, let's take a post-it here. Post-it note has line symmetry, right? I could cut it different ways, but it also has rotational symmetry. The idea that I could take a post-it note and I can rotate it less than 360 degrees and it ends up landing on itself. That's a form of rotational symmetry. So if I look at this semicircle, I could try rotating it, but I'd have to rotate it 360 degrees before it landed on itself. So this one has line symmetry, but not rotational symmetry. Now let's look at the star. Does it have line symmetry? Yeah, it has a lot of line symmetries. I could draw lines, right down the middle. I could draw a line out to the side like this. I could draw a lot of different lines on this star, different ways to fold this in half. So line symmetry, that's a thumbs up. Does it have rotational symmetry? It sure does. I can take this and rotate the corner over to here, and in less than 360 degrees, I can create the exact same image just by rotating it. So the star would have line symmetry and rotational symmetry. Let's look at this last shape. I made up this shape kind of to create an example. Does this have line symmetry? Well, the temptation might be to draw the line right down the middle like this, and you would cut it in half, but that's not symmetry, because this piece, this corner right here, would end up over here. It wouldn't land on the other corner. So even though it looks like it might have line symmetry, it doesn't. Even if you try to cut it horizontally, it's not going to fold correctly. However, it does have rotational symmetry, right? I could take this and rotate it around, and in less than 360 degrees, end it back where it was to begin with. So this would have rotational symmetry, but not line symmetry. And there are shapes out there that just don't have any type of symmetry, but we're going to focus on these two types of symmetry here in this video. So your assignment is to do a couple IXLs. We're going to have you guys actually do all 4 of these symmetry IXLs, and they are pretty easy. You should be able to get them to 100, all 4 of them, in really no time at all. So the first one says which picture has symmetry, and so you can check and see which one seems to have symmetry. And this one, I think, you'd end up with the windows, right? You could draw a line and the windows would match up. This board might be tempting because it looks like it has symmetry, and in shapes it does, but it doesn't in colors. So the colors do matter here. So the first one's find symmetry, line symmetry. The second one's find rotational symmetry. So in this case, this would be a no. We could rotate it on top of itself, but the colors won't match. And so again, each of these, this would be yes, right? We could rotate this part way through and get rotational symmetry. Now the hardest part that students have with this lesson is actually on this IXL. Towards the end, it asks questions like this. Now let me actually go back here and let me set this up so I can write on this. So it asks, this has rotational symmetry. What is the smallest number of degrees you would need to rotate this image for it to look the same? So here's what I would encourage you to do. This one's pretty easy. It looks like 180. It is 180. But I would figure out how many times you can rotate it in 360 degrees. I can rotate this once, twice, right? So if I have 360 degrees in a full circle, the number of times I can rotate it will tell me the degrees of rotation. So my degrees of rotation here, the degrees are 180. So let's try that and then look at another example. All right. Now this is probably a better example to kind of show you this principle. Once again, we can rotate this soccer ball so that it looks the same, but I can rotate it 1, 2, 3, 4, 5 times. If I kind of think about how many times I can turn this, I can turn it 5 times. So once again, I'm going to say whole circle is 360 divided by 5, and I get 72 as my answer. So all of that kind of shows us how to do these problems. Let's take a look at the other IXLs, and then I'll let you guys get working. This one asks you to draw the lines of symmetry, so you can kind of click and that'll draw your lines of symmetry. If you want more lines, you can hit this plus sign and you can draw more lines if you want. Obviously that's not a line of symmetry and you can get rid of it by clicking the 2 points. And then your last one is counting the lines of symmetry. You don't get to draw them this time, you just need to know how many lines of symmetry does each shape have. You should be able to get all 4 of these to 100 with relative ease. Hopefully this works well. If you have issues, as always, shoot me an email if you need help. So have fun, get all 4 of these to 100, and that's a day's worth of work.